Namaskaram. Today we will discuss chain rule for a multivariable function. Okay, this is the chain rule for one variable function. That means y is a function of u and u is a function of x. Then ultimately y is equal to f of g of x. That means y is a function of x. So we can differentiate y with respect to x. How? That is dy by dx. Dy by dx is equal to dy by du into du by dx. Okay, for example, you consider y is equal to sin x cube. And what is our f of u? Here f of u is sin u. And what about our u? U is x cube. So this is our g of x, right? So we know how to differentiate this f with respect to u, or how to differentiate this y with respect to x. It means dy by dx. That is equal to derivative of y with respect to u. So here our f of u is sin u. So that is cos u. Cos u means what is u? U is x cube. So cos x cube into du by dx. Du by dx means 3x square. So this is the working rule. Okay. Analogously, we can define this chain rule for multivariable function. Let's see. Okay, this is the analogous statement of problem in two variable function. If x is equal to x of t and y is equal to y of t, that means x and y are functions of t, right? Are differentiable at t, and z is equal to function of xy. Then what about z? Now z is equal to f of, yes, z is equal to f of x of t comma y of t. Ultimately, now we can express z is in terms of t, right? That means we can differentiate z with respect to t. So the question is, what is dz by dt, right? Okay, then this is the chain rule of two variable function. Dz by dt is equal to dou z by dou x into dx by dt plus dou z by dou y into dy by dt. Okay. A similar result holds for three variable function. Suppose w depends x y t and x and x y and t x y sorry w, suppose w depends x y and z, and x y and z also depends t. Then it is clear that you can convert our w in terms of t, right? So we can find dw dt. So this is the rule for three variable case. Dw dt is equal to dou w by dou x into dx by dt plus dou w by dou y into dy by dt plus dou w by dou z into dz by dt. Okay. Okay, this is the graphical representation of our chain rule. We know that z is ultimately f of x of t comma y of t. That means z depends t. So first z depends x and z depends y, and y depends only t, x also depends t. So the question is how to find the derivative of z with respect to t. So actually we have two branches. You can think this as a two branches of z. So first you differentiate z with respect to x, but z depends two variables. That's why we use partial derivative into derivative of x with respect to t. Here x depends only one independent variable. That's why we use normal derivative dx by dt plus next branch derivative of z with respect to y, that is dou z by dou y into dy by dt. Clear? So this is the idea. Okay, consider this problem. Suppose that z is equal to x square y and x is equal to t square and y is equal to t cube. So it is clear that now z is in terms of t, right? Use the chain rule to find dz by dt and check the result by expressing z as a function of t and differentiating directly. Okay, so we have to find dz by dt in two different ways. First, we have to find this dz by dt using chain rule. Next, we have to express, we can express this z in terms of t. Then you have to differentiate with respect to t. Okay. So first one is our chain rule. We know our chain rule is dz by dt is equal to dou z by dou x into dx by dt plus dou z by dou y into dy by dt. So what about our dou z by dou x? What is dou z by dou x? To differentiate this z with respect to x. So this become 2xy, right? Dx by dt. What is our x? X is t square. So this become 2t plus. What is our dou z by dou y? We have to differentiate with respect to y. That is x square, right? Then dy by dt, that is 3t square, right? So actually we have to find this derivative in terms of t. So we have to convert everything in terms of t. Okay. So we have to convert x, y, everything in terms of t. What is x? X is t square. So 2t square, y is t cube into 2t plus x square. That is t square whole square into 3t square. Right. So you can simplify this. Yes, this is 4t raised to 6. This is 3t raised to 6. So total 4 plus 3 7t raised to 6. Okay. So dz by dt equal to 7t raised to 6. Next, we have to express z in terms of t, then differentiate. Z is equal to x square y. What is x? T square. So this become t square whole square into y, t cube. That is equal to what? That is equal to t raised to 7. So next we have to find dz by dt. So that is 7t raised to 6. The same answer. Okay. Second problem. Suppose that w equal to square root of x square plus y square plus z square. Now it's a 3 variable function, right? And x equal to cos theta, y is equal to sin theta, z equal to tan theta. Use chain rule to find dw by d theta. It's clear that w is in terms of theta. Okay, so dw d theta when theta equal to pi by 4. Okay, what is the graphical representation of this given functions? Yes, w depends x, y, z, and x, y, and z all depends theta. Okay, so what about the chain rule? First of all, we have to differentiate along this leg plus this leg plus this leg. So dw by d theta equal to dou w by dou x into dx by d theta plus dou w by dou y into dy by d theta plus dou w by dou z into dz by d theta. Okay. Next we have to find all these derivatives, substitute in this equation. Okay, so what about dou z by dou x? To differentiate this with respect to x, this become, okay, we know the derivative of root x is equal to 1 by 2 root x. So that's why this become 1 by 2 into x square plus y square plus z square raised to minus 1 by 2 into derivative of inside, that is 2x. Okay, next is dx by d theta. Okay, x is given cos theta, so its derivative is minus sin theta. Similarly, this term, is nothing, dou w by dou y into dy by d theta, that is cos theta, and this term is our dou w by dou z into dz by d theta. Okay, then question is we have to find dw by d theta at theta equal to pi by 4. So we have to substitute theta equal to pi by 4 in all these terms. So what is the value of x when theta equal to pi by 4? When theta equal to pi by 4, what about x? X is cos theta, so this become cos pi by 4. And what about y? Y is sin pi by 4. And what about z at pi by 4? That is tan pi by 4. Okay. And we know that cos pi by 4 is 1 by root 2, sin pi by 4 is 1 by root 2, tan pi by 4 equal to 1. Then now you can substitute everything in this expression. This gives, okay, 1 by 2 into x square. X is 1 by root 2, so this become 1 by 2. 1 by 2 plus 1 by 2 plus 1 all raised to minus 1 by 2. Then 2 into x. 2 into x is 1 by root 2, that is 2 into 1 by root 2 into minus sin theta minus sin pi by 4. Sin pi by 4 by sin pi by 4 is 1 by root 2. Okay. Similarly, the second term into 2 into y. Y is again 1 by root 2 into cos theta. Cos theta is 1 by root 2. As similarly, last term is, and okay. And what about this one? This term is nothing. 1 by 2 plus 1 by 2 plus, that is 2. 2 raised to minus 1 by 2. What is that? 2 raised to minus 1 by 2 is nothing. 1 by root 2. That's why this term is 1 by root 2. Okay. This 1 by 2 is this one into 2. 2 into z. What is z? Z is 1. So 2 into z is 2. Then sec square theta. And what is sec square theta? What is sec theta? 1 by cos theta. So 1 by cos theta means root 2. There is a square. That's why this become 2. Okay. Then you can simplify this. And it is clear that 1 by 2 into root 2. 1 by 2 root 2 is common. This is 1 by 2 root 2. This part is common. So take outside. So remaining time is this is minus 2 by 2. Here it is 2 by 2. Here it is 4. Okay. You can cancel these two. So this become 1 by 2 root 2 into 4. That is root 2. So dw by d theta at theta equal to pi by 4 is root 2. Okay. Okay. Next one, chain rule for partial derivative. We consider a function z is equal to function of x and x and y are again functions of u and v, right? So what is a tree diagram of this representation? Yes, z depends x and x and y depends u and v. So ultimately z is in terms of u and v, right? So we can find derivative of z with respect to u. Similarly, you can find derivative of z with respect to v. Okay, and this is the rule for evaluating our partial derivatives using chain rule. So dou z by dou u is equal to, first you differentiate along this leg, dou z by dou x into derivative of x with respect to u. But here x depends two variables. That's why we use the partial derivative dou z by dou x plus along this leg dou z by dou y into dou y by dou u. Okay, similarly you can define the partial derivative of z with respect to v. We can also extend this result to any number of variables. In particular, for three variable case, suppose w depends x, y, and z, and x, y, z depends u and v. Then what happened? Then what is? Then it is clear that now w is a function of u and v, right? So you can find dou w by dou u and dou w by dou v, and this is the rule for This is the chain rule for evaluating dou w by dou u and dou w by dou v. It's analogous to this one. Okay. Okay, consider another problem. Given that z is equal to e raised to xy and x is equal to 2u plus v and y is equal to u by v. We have to find dou z by dou u and dou z by dou v. And what is the tree diagram of this problem? We have z depends x and y, right? Z depends x and y. And what about x and y? X and y both depends u and v, right? So you can find derivative of z with respect to u as well as derivative of z with respect to v using our chain rule. So what is the chain rule for evaluating dou z by dou u? So this is the chain rule for dou z by dou u. So you have to find just all these partial derivatives and substitute. So this become, okay, what is the derivative of z with respect to x by treating y as a constant? This y e raised to xy, e raised to xy into derivative of xy with respect to x, that is y, okay, into derivative of x with respect to u, that is dou x by dou u, that is 2. So this is derivative of z with respect to y, and this is nothing dou y by dou u. Dou y by dou u means we can treat 1 by v as a constant, so this become 1 by v. Here e raised to xy is common, you can take outside, so this become e raised to xy into 2y plus x by v. Okay, we have to find this derivative in terms of u and v, right? Ultimately we have to find, we know that z is in terms of u and v, so we have to find this derivative in terms of u and v. How? By substituting this y and x in terms of u and v. And what is y? Y is u by v and x is 2u plus v. So you can substitute these two values instead of x and y. So this expression become, so this become e raised to x is 2u plus v into y is u by v into 2 into y, 2 into u by v plus x is our 2u plus v by v. Okay, and again you can compare here, denominator same, and in numerator 2u is there, another 2u is there, so this become 4u, so 4u plus v by v. So this expression become e raised to 2u plus v into u by v into 4u plus v by v. Okay, so this is our dou z by dou u. Yes, 4u by v, yes, this v by v become 1, like that. That's anyway, they are same. Okay, similarly you can find our second partial derivative using the analogous rule. Okay, analogous to this, what is our dou z by dou v? First you differentiate along this leg, that means dou z by dou x into dou x by dou v plus dou z by dou y into dou y by dou v. Okay. So this is our dou z by dou x, and what is dou x by dou v? Dou x by dou v is 1. Okay. Similarly, this is dou z by dou y, and this is dou y by dou v. And e raised to xy is common, you can take outside. And similar to previous case, next we have to replace all xy's in terms of u and v using this relation. Okay. So upon simplification, this becomes like this: minus 2u square by v square e raised to 2u plus v into v by u. Okay. This is your homework. Thank you.